In this example, we will find the higher order derivatives of the trig function. In this case, we're going to find y double prime, or the second derivative. In part A, y equals sine x. So then the y prime is the derivative of the sine x, which is cosine x. And then the second derivative, or the derivative of the cosine x, is negative because the cosine begins with the same. Y double prime is negative sine x. Part B, y equals cotangent x. Cotangent begins with the letter C. So the y prime is negative cosecant square x. Next, we're going to find y double prime. The y double prime is the derivative of negative cosecant square x. We can rewrite the cosecant square x as cosecant x times cosecant x with the negative sign in the front. And then we're going to use the product rule on the side notes here. And we treat negative as a coefficient. So the first one is a u, second one is a v. U is the cosecant x, which is the same as a v. U prime is negative cosecant x cotangent x, which is the same as the v prime. Use the product rule. Negative u times v plus u times v prime plus u prime times v, or negative of the u is cosecant x times the v prime, which is negative cosecant x cotangent x, plus the u prime, or negative cosecant x cotangent x, multiplied by the v, which is cosecant x. As you notice, u and v are the same. U prime and v prime are the same. So we have the twice of the terms here. Therefore, we have negative becomes positive, and twice of the product of the cosecant x, which is cosecant squared, multiplied by the cotangent x. Another example, y equals e to the x sine x, and we are going to find y double prime. First, to find y prime, use the product rule. Let u be e to the x, and the v sine x. The u prime is e to the x, and the v prime is cosine x. Y prime is u v prime plus u prime times v. The u is e to the x, the v prime is cosine x. The u prime e to the x, the v is sine x. So we can rewrite it in the form that we have e to the x as a common factor. Then the y prime is e to the x times cosine x plus sine x. And next we're gonna find y double prime. As we see, the y prime is in the product of the two terms. One is e to the x, the other one is cosine x plus sine x. So we're gonna set up another set of the u and v. Let u be e to the x, and the v be cosine x plus sine x. On the side notes, as we know u as e to the x, u prime is e to the x. The v, which is the cosine x plus sine x, the v prime is negative sine x plus cosine x. So then the y double prime is u v prime plus u prime times v. The new set of the u and v, as u is e to the x, the v prime is negative sine x plus cosine x, plus the u prime, which is e to the x, the v is cosine x plus sine x. Then simplify. Now we see e to the x as the common factor, and then regroup the rest of the terms together as negative sine x plus cosine x plus cosine x plus sine x minus sine and plus sine they are cancelled. Now becomes 2 cosine of the x multiplied by e to the x as the second derivative of this function. Additional problem. Evaluate the following limit or state that it doesn't exist. The hint, identify the limit as the derivative of a function f at a point A. We have seen this pattern before as the limit tangent x plus 1 divided by x minus 3 pi over 4 as x approaches 3 pi over 4. This is the same pattern as the limit of the function f of x minus the function f at a divided by x minus a as x approaches a as the limit of the different quotient, which is the same as the derivative at the point A. Given that the limit of the tangent x plus 1 divided by x minus 3 pi over 4 as x approaches 3 pi over 4, we see now a is 3 pi over 4. And the function f of x is the tangent of the x. Let's check what is the f at a or the f at 3 pi over 4. The 3 pi over 4 replaced in the x term. Then we have the tangent of 3 pi over 4. 3 pi over 4 is in the second quadrant, so the tangent of 3 pi over 4 is negative or negative 1. So this is the same as the tangent x minus negative 1. That means we have the right set of the terms to move on to the next step. From all terms here, we're going to use the limit definition of the derivative as the limit of the fx minus fa divided by x minus a. X approaches a equals the derivative of the f prime a. Therefore, this limit is the same as the derivative of the f prime at a, which is at 3 pi over 4. How do we find this? This is the derivative of the function at the point 3 pi over 4. What is our function? Our function is the tangent x. So this is the same as the derivative of the function, which is the tangent x. Evaluate where x equals 3 pi over 4. The derivative of the tangent is secant square x, and then we replace x with the value 3 pi over 4. Secant square of 3 pi over 4, which is 1 over cosine of 3 pi over 4 quantity squared. Cosine of 3 pi over 4 is square root negative square root 2 over 2. So 1 divided by negative square root 2 over 2 squared. That gives us 1 over 2 over 4 or becomes 2 as a result.